Let's start off by looking at this. I've already done the factor trees for these two different sets of numbers. This gets kind of weird. But if I'm trying to find the LCM for this set of numbers, it's sort of strange. First of all, for the greatest common factor, and I probably should erase this and explain it as I go. It makes a little more sense. Okay? The greatest common factor for these guys is going to be 1. How do I know? 7's prime. This has 2's, but 7's prime, therefore, it's just 1. None of these are going to be able to be a GCF. Let's get rid of that right now, right? If we're actually trying to figure out what is the one factor all these guys can fit in, well, that becomes a little different. First of all, if I take the factors of 4, which is 2 times 2, and 7, I can recombine these to make a new number, 28. And that's the one I'm going to put on this side. I put 8 on the other side. 8 is equal to 2 times 2 times 2, and I put him over here. Now, I'm going to break these apart, okay? So we have 2 2's, which go in the center because they're on both sides. A 2 over here. I put a 7 over here, okay? And now I can find my LCM. My LCM would be equal to 7 times 2 is 14 times 2 is 28 times 2 is 56. Let's check it, okay? And how you can check this is 4 goes into 56. 1 times 4 is 4. Bring down the 1, 6, 14. Okay? So 4 times 14, well, this would be a dot, is equal to 56. How about 7? Let's go. 7 goes into 56. Fax Pro, 8 times. 7 times 8 equals 56. And now obviously the last one's 8 times 7 equals 56. So it's all the multiple of 56. Okay? It's a little weird, but that's the way to do it. You combine one of them and then do your factor box that way. Makes it a little easier than trying to do 3 of them in a Venn diagram, just being honest, right? So hopefully that makes a little bit of sense. There's another way you can do it, and I'll show you it right now. So I'm going to take my, I could take my factors again. For 4, it's what? 2 and 2, right? We got this, right? 7, we don't have anything. And 8, we have what? 2. Then you have 4, and then you have 2 and 2, okay? So I'm reestablishing the obvious. So if I take 4 and I put its factors, 2 times 2, right? 7 only has what? 7, right? Doesn't have anything else. We have 8, and we have 2 times 2 times 2, okay? Now, this is another way to find the LCM, which you may find quicker than doing a Venn box, right? My LCM will be anything, okay, that is found at least once in this thing, right? So see how 2's in here twice? I could cross out 2 2's and just put 1. I cross out 2 2's and just put 1. It's covered in both of them, right? 7 has to be covered, so we'll put here, here. And then the last one, 2, will be here. So you just multiply it all up, you get 56. All right. It's not too bad. I'm going to try another one using this method, like 21 and 30. And you'll see how this works, okay? 21 over here, 30 over here. 21 is 3 times 7. And 30 is 3 times 10. And it's also 2 times 5, right? Circle my primes. 1, 2, 3. 1, 2, right? So I'm going to take factors of 21, put this here. Factors of 30, put it here. 21 is 3 times 7. This one is 3 times 2 times 5. Okay? Drop a line. I only have to include the 3 one time. So this goes away. Put 1, 3. This is my LCM. Then I got to take down the 7. I got to take down the 2. And then I got to take down the 5. So my answer would be 7 times 5 is 35. 35 times 5. So that'd be 5 times 5 is 25. If I get rid of the 2. 5 times 3 is 15, 16, 17. 175 would be my LCM. Okay. Hopefully that makes sense. There's no way of doing it. You only have to include the number once. If it's included, then you cross it out in the other one, so you don't have to worry about it.